So the fourth and final part of the walkthrough of case study ex4 is going to demonstrate some other interesting things. In particular, we're going to show how to apply flat map and subscribe as well as flux sync to create, multiply, and display big fraction objects asynchronously. And this example is going to apply an overflow strategy. So we're going to use the two-parameter version of create, which is going to provide an emitter, which will emit the results, and then an overflow strategy that will handle it when things go too fast. And we're also going to see some other examples of using mono operators as well. This subscriber is used in a blocking way. However, it is also back pressure unaware, but it has an overflow strategy set. So you'll see what happens when the events show up faster than it can process them. So once again, we look at the ex4 project in my reactive flux folder in my live lessons GitHub repository. So here we are once again in my ex4 project, except this time we're going to take a look at the test fraction multiplication overflow strategy test method. So let's go ahead and zoom over to that one. And you can see that we, in this case, make a blocking subscriber that is going to be back pressure unaware. So we don't exert back pressure this time. And we're going to set the count of the number of fractions to generate to be very large so that we'll generate the events faster than the consumer or the subscriber can keep up. We then use the two-parameter version of create. And you can see here the first parameter is one that's going to just generate a boatload of events. We'll take a look at that in a second. And then the second parameter is going to instruct Project Reactor's flux implementation to generate an exception when overflow occurs. And overflow is going to occur very quickly, as you'll see. Let's first take a look at make emitter. So make emitter is this helper method. We pass in a count and a string buffer to do logging. And then we're going to create an emitter, which is a consumer to a flux sync of big fractions. And this emitter is just going to blast out random big fractions without concern for back pressure. So we will look later at how to put back pressure into this stuff, but for right now, we don't care. So here what it does is we just go into a good old for loop. We could have done this in a more reactive way if we wanted to by using something like the flux range operator, but this is simple enough. So we make ourselves a big fraction that's random and unreduced, and then we're going to check to see if we've been canceled. If we've not been canceled, we emit that item, so it's just going to blast them out as quickly as we can. And when we're all set running through everything in that loop, we're going to indicate completion by calling the complete method on the sync, which is essentially like generating the end of file event. So that's what the emitter does. And we are going to get all those events, which are going to be coming in one thread. And then we're going to use the overflow strategy. What we're going to do here, as you can see, is we're going to use flat map and multiply fraction to multiply as many things as we can get before the buffer is, or not the buffer, before the downstream is overwhelmed by the incoming events. And we're going to do as much as we can before we get an error. We now subscribe using the back pressure subscriber, which is back pressure unaware in this case. And we then have the calling thread block waiting for things to be done. So let's run the code. And this particular run, we're going to skip over the test fraction multiplications blocking subscriber 1 and blocking subscriber 2 method, and instead look at the results for test fraction multiplications back pressure strategy. So you can see what's happening here. We start out by publishing some items, and I have a little nice debugging thing in there that tells you how many things have been processed so we don't have to watch them all whiz by. So you can see that some processing is taking place for these items. A lot of stuff is publishing. These things are being processed in other threads of control. And you can see that we were making some good progress here, publishing stuff, but then we published things too quickly, and we received the overflow exception. And when the overflow exception is received, that's because the subscriber couldn't keep up with the signals that are being generated by the publisher. And we then have this exception. So we bail out at the point when the exception occurs. Of course, we could have set other policies besides the error overflow strategy, and we will show that in some other examples later. So that's basically the walkthrough of all these different techniques, which now gives you a very good idea of how to implement blocking subscribers that are either back pressure aware or not, and also how to use the 2-parameter version of create from the flux.